Here are the solutions for the extension part of the conics mock exam. Number one, what are the foci of the hyperbola? And it gives us a hyperbola here. This is h, this is k, this is a squared, and this is b squared. Now you notice that this form has basically the y squared minus x squared equals 1 format, right? It's the y first and the x second. So that means that instead of a left side, right side parabola, it's a top and bottom parabola. No, I'm sorry, not parabola, hyperbola. So it looks like that, right? So because of that, we know that the foci are kind of stacked on top of each other like that, okay? So they're vertically oriented. So again, first thing we're going to do is we're going to figure out what the c value is, and we know that for a parabola, the equation to find the focal length, or c, is a squared plus b squared equals c squared. A squared plus b squared is 64 plus 78. Which is equal to 142. Is that right? Yeah, 142. So c squared is equal to 142. So basically c is the square root of 142. And it says to simplify any radicals. So square root of 142, let's factor 142. So 142 is 71 and 2, and basically that's as far as you can go, right? 71 is a prime number, 2 is a prime number. So actually, square root of 142, that's the simplest possible way of expressing that radical. Okay, so we know that c equals square root of 142. We know that the foci are vertically oriented. We know that the middle center point is 2, negative 4, right? If we're going to figure out where the foci are in relation to this, we're going to take the y value and we are going to add square root of 142, and then we are also going to subtract square root of 142 to get the two possible values. So one of the foci would be 2, negative 4 plus square root of 142. And the other foci would be, the other focus would be negative 4 minus square root of 142. Okay? All right. What is the focus and the directrix of this parabola? Okay, and do you notice that this parabola is oriented sideways instead of up and down? Sideways in which direction? Well, since there's a negative here, and not only is it sideways, but it's opening to the left. Okay? And normally it would cross at the origin, but since there's a minus 4 here, it's shifting the x value to the left by 4. Okay? So the vertex is going to be negative 4, 0. Okay, and we can verify that by putting x equals negative 4, putting y equals 0, making sure that that works, and it does. Okay. Now, where is the focus in this case? Well, the focus has to be here, right? Because it's inside the parabola's open part, and the directrix would be like here. Okay. What is the distance between the vertex and the focus? Well, it's the focal length, which in the case of a parabola is p over 1 or 4a. And the a value here is a half. And you don't need to put the negative half. You could just put regular half. And we can see that 1 over 2, so the p value is a half, right? So I'm going to take the vertex, and then I'm going to add to the x coordinate the p value, or I'm going to subtract the p value. In this case, I want to subtract, right? Because the focus is 1/2 to the left of negative 4, 0. So I'm going to subtract negative 1/2, and I'm going to get negative 4.5, 0. Right? Okay, that's my answer. Oh, what is the directrix? Now the directrix. So the directrix is 1/2 to the right of -4, 0. And then it would be a vertical line, so it would be x equals -3.5. So this would be the equation of the directrix, right? Okay, let's go to number 3. What are the foci of the ellipse x squared over 4 plus y minus 1 quantity squared divided by 16 equals 1? So let's identify all the important parameters. A squared, b squared. H is 0, right? Because there's no h value here, and the k value is 1. So our center would be 0, 1. A value is 2, and the b value is 4. Okay. And remember, to find the foci of the focal length of the ellipse, we use the equation a squared equals b squared plus c squared, where c is the focal length, okay? And in this case, the long length is actually b and not the a, so we're going to switch the formula so that the longest length is here. So if it's b, then we're going to put the longest length here. So it was 4 squared equals 2 squared plus c squared. So that means 16 equals 4 plus c squared. C squared is equal to 12. C is equal to the square root of 12, which is equal to, you could write that that's 3 square root of 2, right? So this is the focal length, the distance of each focus from the center. The center is 0, 1. Is this ellipse a wide ellipse or a tall ellipse? Well, since the b value is longer, that means that it's a tall ellipse. So if it's a tall ellipse, then the foci are oriented vertically. So you're going to take the 0, 1, and then you're going to change the y value. We're going to add, square root of 12. And we're going to subtract square root of 12 to the y value to get the two other values of y. So we have 0, 1 plus 3 square root of 2. And the other one would be 0, 1 minus 3 square root of 2. Okay. So those are the two foci of the ellipse. Number 4. Now we're going to start the probability problems. In an experiment, the probability that event A occurs is 4/7. The probability that event B occurs is 4/5. And the probability that event A occurs, given that B occurs, is 4/7. Are A and B independent events? Justify your answer. Okay. So the probability of A is equal to 4/7. The probability of B is equal to 4/5. The probability that A occurs, given that B occurs, is 4/7. Okay. So, the definition of independent events means that the probability of A is equal to the probability of A happens given that B happens. So in this case, yes, they are equal. So we say yes, independent, because the probability of A is equal to the probability of A given B. Okay, number 5. Sorry about this mess here. This is misprint. Anna bought 55 seeds in order to plant an herb garden for her grandma. Of the seeds bought, 12 were time seeds. If Anna chooses to plant 52 random seeds on the east side of the garden, what is the probability that exactly 11 of the chosen seeds are time seeds? Okay, so here we're going to use the concept of combinations and all the different combinations of pulling out, let's see, 11, no wait. Okay, 52 seeds out of 55 seeds, what are the ways of choosing 52 seeds out of 55 seeds? Okay, so that would be 55 chooses 52, and that's in the denominator, right? In the numerator, we want 12 times seeds, and we want to choose 11 of those time seeds out. And of the remaining 41 seeds, we want them to be non-time seeds. So the non-time seeds would be 55 minus 12, which would be 43, right? Okay. So we have 12 chooses 11, 43 chooses 41, and 55 chooses 52. And we can write each one of these as a factorial. So the first one is going to be 12 times, actually 12 chooses 11 is going to be just 12, okay? 12 chooses 11 is just 12. 43 chooses 41 is 43 times 42 divided by 2 times 1. And then 55 chooses 52 is equal to 55 times 54 times 53 divided by 3 times 2 times 1. Okay, and if you don't know how to do this, you need to do the part of Excel where they show you how to do permutations and combinations. Okay, now I'm going to simplify this. So the 2, 1 cancels out here. I can cancel this out with this. I get 4. So I have 43 times 42 times 4 divided by 55 times 54 times 53. We're going to use the calculator for that. Okay, so one dangerous thing about this is not putting parentheses on the numerator and denominator. So let's be careful about that. I'm going to put 4 times, let's put parentheses on both. So I'm going to put parentheses 4 times 43 times 42 divided by parentheses 55 times 54 times 53. And the answer is 0.0459. 0.0459. Okay. Number 6. The table gives a set of outcomes and their probabilities. Let A be the event the outcome is greater than 2. Let B the event that the outcome is prime. Find A given that B occurs. Okay. So let's first find the probability of A. The probability of A is the probability that the outcome is greater than 2. Greater than 2 would be 3 and 4, right? So the probability that 3 and 4 come up would be 0.4 plus 0.1, which is 0.5. Okay. Probability of B is the probability that the outcome is prime. The numbers that are prime are 1, 2, and 3. So the probability that it's prime would be 0.4 plus 0.4 plus 0.1, which would be 0.9. What about the probability that A and B happen? And why am I figuring that out? Because there's a formula which says that the probability of A given B is equal to the probability of A intersect B divided by the probability of B. So we know this, we know this. Now we just need to figure out A intersect B. So A intersect B would be this probability plus, or the intersection between these two probabilities, which is 0.4. Okay? So we'll put 0.4 here. And now we'll use this formula here to figure out what's the probability of A given B. It would be 0.4 divided by the probability of B, which is 0.9. Okay. And so the answer is 4/9. Okay. 7. A health instructor surveyed all her students and tallied the results. The first survey question asked, do you adhere to a vegetarian diet or omnivorous diet? Omnivorous? 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 I think it's omnivorous. The second question asks, if you were to buy a pet today, what animal would it be? The probability that a student adheres to a vegetarian diet is 0.37. The probability that a student would buy a snake is 0.59. And the probability that a student adheres to a vegetarian diet or buy a snake is 0.8. What would be the probability that a randomly chosen adult adheres to a vegetarian diet and would buy a snake? Okay, so let's name the probability that they buy a snake S and the probability of a vegetarian diet V. Okay, so the probability that a student adheres to a vegetarian diet is 0.37. PV equals 0.37. The probability a student would buy a snake is 0.59. The probability that a student adheres to a vegetarian diet or would buy a snake, which would be V intersect or union S, is 0.8. What is the probability that a randomly chosen student adheres to the vegetarian diet and would buy a snake? So that would be V intersect S. Okay, so there is the addition property, which says that if you have the probability of V intersect union S, that is equal to the probability of V plus probability of V plus the probability of S minus the probability of V intersect S, because that's the overlap. So 0.37 plus 0.59 minus, we don't know, okay, and that's equal to 0.8. Okay, so now let's do some algebra and figure out what PV intersect S would be. Okay, PV intersect S. So I'm just going to do some algebra here. Move that over here. 0.37 plus 0.59 minus 0.8. 0.37 plus 0.59 minus 0.8, 0.16. So the answer is 0.16. Okay, last one. Cohen has a collection of marbles of different sizes and colors. What is the probability that a randomly selected marble is green given that the marble is small? Okay, so the marble is small, and of the small marbles, how many are green? 6. Okay, so the way you do this is you say the probability of, I'll use the letters from here. Probability that a marble is green, given that it's small, is equal to the probability that it's green and small divided by the probability that it's small. Okay, green and small, there is just 6 marbles, right, out of a total of 11, 17, 18, 19, 25, 26, 29. So 6 out of 29, right? The probability that a marble is small is 8, 9, 10, 11, 12. 12 out of 29. Okay, so the 29s cancel out. We get 6/12. And the probability is a half. Is that it? That's it.